Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. For a Newman projection looking down the C1, CH3 bond of methylcyclohexane, i.e., the exocyclic C bond, the front carbon is C1 of the ring and the back carbon bears CH3, H, and H. The lowest energy conformer corresponds to the equatorial position of the methyl group on the cyclohexane ring, which in Newman projection terms means the methyl group on the back carbon is anti-180 degrees to the C1 ring bond, that is axial, i.e., the ring portion going up. Moving on to the next step. Identify the bond being examined. The structure shows a cyclohexane ring attached to a CH3, H group via a bold bond, with a Newman projection arrow indicating we look down the ring IChO C bond. Moving on to the next step. For methylcyclohexane in the equatorial conformation, the methyl group is equatorial. In the Newman projection down the C1, ChO bond, the equatorial methyl corresponds to the methyl on the back carbon being gauche to the two ring carbons adjacent to C1, and the arrangement places both H atoms on the back carbon gauche or anti in specific positions. And for the final step, the lowest energy Newman projection is the one where the methyl group on the back carbon is anti to one of the ring bonds and the overall conformation reflects the chair with equatorial methyl. In option C, the back carbon shows H and H flanking with the ring carbon on top of the front carbon, and the methyl is in the anti-position relative to the ring. This corresponds to the equatorial chair conformation of methylcyclohexane, which is the lowest energy conformer. Equatorial methyl is ~1.74 kcal-mol more stable than axial methyl. Eliminate other options. Option A places CH3 on top, axial-like, eclipsed or gauche with ring bonds, higher energy. Option B places CH3 gauche in a less favorable arrangement. Option D shows two CH3 groups which does not match the monosubstituted compound. Option C correctly depicts the anti-arrangement of CH3 relative to the ring backbone bond, corresponding to the equatorial methylcyclohexane chair, the global minimum energy conformer. Therefore, the correct answer is C. Therefore, the correct answer is option C.